Here we have a pre-calculus problem. So here we have a complex plane. So because the vertical axis is imaginary, then the horizontal axis is real. And let's go with the question here. So which coordinates represent the plotted point? Check all that apply. So there is a point plotted over here, and among the given points over here, we have to find the one which represents the plotted point over here. So okay, so I think I will have multiple answers for this one. Okay, so the first thing what we need to do is, so we have to look at the points captured over here. The first 4 points are given in polar form, that is in the form of like r comma theta. So the last 3 are given in a rectangular form. So among the points given in rectangular form, easily we can find the one which represents a plotted point over here. So when I look at the plotted point over here, the x coordinate is -3 and y coordinate is 2. So it's going to be -3 comma 2. So among the points given in rectangular form, so the point over here represents a plotted point. So this one is correct, -3 comma 2. Okay, now we have to find so the points which are given in polar form, so which represents the plotted point. So for that, what we need to do is we have to write the point over here in complex number form. So that is -3 positive 2i. So here I multiplied the y coordinate by I because here the vertical axis is imaginary. So I multiply the y coordinate by I. Okay, now to get the polar form of a point which represents this plotted point, so what we need to do is we have to write this given complex number -3 positive 2i in polar form. So that is equal to r times cosine theta positive I times sine theta. Okay, so first let's get the value for, so to get the value for what we need to do is we have to take so absolute value of this complex number -3 positive 2i. So r is equal to absolute value of -3 positive 2i. Okay, so if I want to get the absolute value of a complex number, what I need to do is I have to take square root and I have to square the real part, that is -3 the whole square positive square of the imaginary part. So here imaginary part is just the coefficient of I, that is 2 alone is imaginary part. We should not include I. When I'm saying imaginary part, we are not supposed to include I. So we just have to consider only the coefficient of I. So when I square the imaginary part, I'll be getting 2 square. So when I take square for -3, it will become 9. When I take square for 2, it will become 4. So I'm getting square root of 13. So the value of R is square root of 13. Okay, now we have to get the value of theta. So actually the angle measure theta will be the terminal side of this angle measure theta must be in the second quadrant because the plotted point is in second quadrant. But to get the angle measure, the terminal side, to get the angle measure the second quadrant, so first I have to get the angle measure alpha, so which is in the first quadrant. So how can I get the angle measure alpha which is in the first quadrant? So there is a formula, that is arctan, that is tan inverse of absolute value of y over x. So actually alpha is the angle measure connected to this theta in the first quadrant. So once I get the angle measure alpha in the first quadrant, it can be converted to the angle measure that is in the second quadrant, that means theta. Okay, now let's find the value of alpha. So alpha is equal to tan inverse of absolute value of, so y means in the given point we have to take the y coordinate, that is 2, and x means we have to take the x coordinate in the given point, that is -3. So alpha is equal to tangent inverse of, so since we have absolute value, this -3 will become +3. So I get 2 over 3. So then I get alpha is equal to tangent inverse of, when I divide 2 over 3, I'm getting 0.666. It keeps going. Okay, now we can use calculator to get the angle measure, which is equal to arctan 0.666. Okay, let me do it. I'm getting alpha is equal to 33.7 degree. So actually it's an approximate value because I just rounded the angle measure which I get for this one to the nearest 10. So I'm getting 33.7 degree. So this angle measure is between 0 to 90. That means it's in first quadrant. So always when we get the value of alpha, it will be in the first quadrant. Now, so we have to get the angle measure theta, which is in the second quadrant, because the plotted point is in the second quadrant. For that, we have to draw the 4 quadrants. Okay, let me do it. Okay, here we have 4 quadrants. Okay, now according to the plotted point we have over here, so the angle measure theta has to be in the second quadrant. Okay, so let me draw the terminal side of the angle measure theta. So here, this is the terminal side of the angle measure theta. Okay, to get the angle measure theta over here, I have to consider this 33.7 as a reference angle over here. So 33.7 degree, I consider this is a reference angle. So to get the angle measure over here, what I need to do is I have to subtract this 33.7 degree reference angle from this 180 degree. So when I subtract this 33.7 degree from this 180 degree, I'll be getting so 146.3 degree. So the polar form of this point can be written as r comma theta. R comma theta means what? So r is already we know that the value of r, that is square root of 13. And what is the theta? Theta is 146.3 degree. Okay, so we find this one square root of 13 comma 146.3 degree over here. So this is also correct. Okay, and also there is another way to get the polar form of the given point. So what should we do? Actually, this length over here in the second quadrant is given by the value of r. So that is square root of 13. So to get the polar to get the point in polar form the other way, so we have to draw a line opposite to this one. So when I draw opposite to this one, so the same length square root of 13 should be taken over here. And 1 second, let me square root of 13. So the length of this line is square root of 13. And whatever reference angle over here, the same should be taken over here, 33.7 degree. Okay, here, so here we have r comma theta. And so the same polar point, so how can we have over here? It will be in the form of negative r comma and the angle measure over here. Okay, so negative r means already we know that so the length of the value of r is square root of 13. Negative r means it will be negative square root of 13. So what must be the angle? So the angle is over here. So always it has to be an acute angle. So but this time, so we move in clockwise direction from 0 to this side. So whenever in angle rotation we do clockwise, the angle measure will be a negative angle measure. So here we have 33.7. So the same angle measure should be taken along with the negative sign. So we have 33.7 degree. So this is also a polar form of the point plotted over here. So we get the point in polar form in 2 ways. One is r comma theta, that is square root of 13 comma 146.3 degree. So other form of the other polar form is a negative square root of 13 comma negative 33.7 degree. So we find this one over here. So this one, and this one. So these 3 coordinates represent the point which is plotted over here.